Hi there, welcome back, and to this, our continuation of our discussion on schema creation, and more specifically, the data definition language. If you recall, in our last meeting, we took a look at comments within DDL and SQL in general, the drop user command, drop user cascade, create user, and then we took a look at privileges, how to create and then grant them to specific roles and or users. Great fun. Now it's time to move on to actual schema objects and how we create and manage those things. Should be great fun. Let's take a look. All right, let's get back to our schema creation log and pick up where we left off. Looks like our next statement is a connect. Cool. If you'll recall, we originally logged into SQL Plus as system to run this script. As system, we created the MyStore user and granted it privs necessary to connect and create schema objects. A little later, we also granted the MyStore user DBA privs with the admin option, so that user's pretty well off with respect to having all their necessary privileges. Now, with this connect statement, the MyStore user is logging into Oracle with the MyStore password. Probably a poor choice of password names with respect to security, but you understand, please, here that this is all just for example. Looks like it worked. Looks like our connection worked because Oracle responded with a connected message. Net. We are no longer executing this script as system, but instead we are now the MyUser or the MyStore user. More accurately, probably, that we're now connected to the MyStore schema as the MyStore user. That's what we want, right? Remember, we do not, under any situation, create any new additional objects within the system account where all the metadata is stored. While we're on the topic, let's quickly learn how to connect to a schema in Oracle SQL Developer. When you first launch SQL Developer going forward, we're just going to call it Developer, you land here on this start page. That's just fine. It's Oracle's way of communicating with you, getting you some tutorials, getting you updated information. For this discussion, we're not really interested. Instead, let's go over here to the upper left-hand corner where in this connection area, we see this nice little green plus sign. Hey, that guy looks promising. Let's click it. Sure enough, after a couple seconds, up comes a new connection creation form. We'll give our connection a name and then fill in the username and password fields appropriately. The rest of all this stuff should work fine for our local RDBMS, so let's just test the connection. Perfect. Looks like we have it set. Now note, if you're connecting to a remote database, you're probably going to need to speak with the DBA about what information is needed for that remote connection, but they'll know and be able to hook you up very quickly. All right, before we move on, we save the connection, hit the connect button, and we're in business. Now, I know we're going through this log as a learning exercise, but if you want an even stronger learning experience, I suggest you go back and log into System, drop and recreate the MyStore user, grant it DBA privs with admin, and now log back into MyStore. We've now cleaned out all the MyStore objects, and you can create these things as we move forward. Great idea, I think, because you're nothing more than practice always makes a better situation. Don't worry, if you do get things messed up, you can always go back and rerun the script to make sure we're all in sync. All right, we should now all be logged into Oracle as the MyStore user, MyStore password situation, and we're ready to start creating some objects. If you're typing along, great. Otherwise, we'll just follow along in the log. Either way, the information should be the same. But again, I do recommend you type as we go here, get that practice in and start learning better. Looks like our first statement here is a create table command. Very cool. Our first real DDL, or data definition language. Let's just read it first before we start breaking it down. It says create table shipping boxes, shipping box ID integer, constraint shipping boxes PK primary key, box length integer not null, box width integer not null, shipping rate numeric 5,2 default 0.00. All right, let's break it down. Looks like we start with the keywords create and table, then specify the table name, which in this case is shipping boxes. We then have a left paren, probably signifying the start of a set. Oh yeah, sure enough. And in this case, a set of fields, the first of which is named shipping box ID and apparently has a data type of integer. Looks like shipping box ID has a constraint on it named shipping box PK, and that constraint is of type primary key. All right, cool, I can understand that. I bet the comma indicates the end of that set element. Again, easy enough. Looks like we next have a field for box length, which is also of type integer but cannot be null. That is, whenever a record is added to the shipping boxes table, this value must be specified. Same for the box width field. Finally, it looks like we have a field to store shipping rate, which is of type numeric, has a maximum length of 5 digits and 2 digits of precision after the decimal. Also looks like that field is left blank during insertion. It automatically gets assigned a default value of 0.0. All right, I get it. It's pretty easy. Okay, before we go on, a quick word on upper versus lower case on all these DDL definitions. Short answer, doesn't matter. Oracle's going to convert everything to uppercase before storing the metadata. You can check this out by double-clicking SQL Developer on shipping boxes table over there on the left-hand side. Up comes all the metadata for that table. All caps. Easy enough. Check it out. All right, you say that was pretty cool, Rick, but what other data types do I have at my disposal within Oracle? Well, the short answer is a bunch. And unfortunately, or fortunately, whichever way you take a look at it, many of them are actually duplicated or redundant. And it's because in 1992, ANSI came out with a bunch of standards that said, here's what data types a RDBMS should support. And in some cases, Oracle did not properly conform to that new standard. As such, they needed to create a second variant on some of their data types. So we're going to see that as we move forward. Not a big deal. It works either way 99% of the time. So let's take a look at what other data types we have by checking out this table. We start with the varchar data type. Varchar stands for variable length string, in this case one with a maximum size of X characters. Now the only difference between varchar and varchar2 is that a varchar properly distinguishes between a null and a zero length string, whereas varchar2 treats them equally. Net, there's not much difference. We'll stick to the varchar to stay compliant, but it doesn't mean anything. We've already touched briefly on number or numeric fields and integers. Bottom line, numerics are simply real values with X number of digits and Y decimal points of precision. Date field is pretty much in your face, so we won't get into it other than to say it does not support decimal seconds, whereas timestamps do. Again, the timestamp data type was simply added to be ANSI compliant and support fractions of a second. I've never used them. Binary float, binary double, my take, unless you're doing astrophysics or something with that level of precision, you should probably just stick with numeric. I've never used either one of them. Only other one up here that's worth our discussion is row ID. Row ID refers to the exact address on disk of a table row. Finally, it is my experienced opinion that blobs, clobs, and any other large, huge chunk of data should be kept in regular files outside the database, with pointers inside the database at those file names. By the way, blob stands for binary large object and clob stands for character-based large objects. Net, get all of them the heck out of my database. You're slowing things down terribly, and standard SQL syntax doesn't work on these crazy things. Alright, now we've beaten the proverbial Oracle data type horse to death. Let's move on and get back to our log and see what's going on with respect to our schema creation. Alright, nothing new in either the address types or countries table creation statement, so let's move down to the table create table state provinces command. We see something here new with respect to the primary key constraint. We had to separate it out because this PK is compound, being made up of both the state, province, and country fields. Alright, cool. The syntax is very straightforward. Again, we see something new with respect to our definition for our foreign key constraint. Looks like it's constraint name is of type foreign key, followed by a comma-separated list of the fields making up that FK. We then specify which table this FK references, followed by a comma-separated list of the fields making up that table's primary key. Okay, straightforward. Again, it's one of those, as soon as I see it, I can copy that. That's not a problem. Okay, nothing new in our log until we get down to the customer addresses table creation statement. So please jump down a little bit and we're all going to pick things back up on the create table customer addresses command. Why do you suppose I left the primary key constraint definition out of this create table statement? No real reason, actually. I'm just making an example. Notice you can create them in the table or you can alter the table subsequently to add a primary key constraint. The two methods are exactly equivalent. I was just making an example here. Also, did you notice my little note there in the table definition? It's true, foreign keys are by default nullable. That is, they may be left blank on initial creation of the record. Alright, again, nothing new now until we get down to the shipments creation statement. So let's go ahead and jump down the log a little bit until you're looking at the create table shipments statement. What I want you to check out with this line is the command that starts with shipment type as a varchar 10. Do you see the rest of that line where it gives a default but then also adds a check constraint? It's one of those, again, I think where once you see the syntax, it's pretty self-explanatory. Shipment type has a default value of full and must be either full or partial. Okay, that makes sense to me. What are we doing? We're enforcing a nice, clean data set. All right, that's probably enough for one lecture. This one was pretty dense, I understand. Let's go back quickly and review what we learned in this one. We started by examining the connect command and also how to create a connection string in Developer. Very good idea. We then examined the create table statement. Very straightforward once you learn the syntax, not a lot of interesting stuff going on there. Other than, there are a couple of different ways to define a primary key, foreign keys. Constraints are interesting in general, and there are a lot of variants on those themes, so you're going to have to dig pretty deep in that one to get it all. We then took a look at all the Oracle data types, both the ANSI and non-ANSI types. In general, my rule of thumb is if it's a clob or a blob, it doesn't belong. It don't put it in your database because it kills performance. And standard SQL syntax does not work with these guys. We then learned how to define a foreign key, whether it was embedded or via an alter statement. It is basically creating a constraint that says this set of fields within a table is referencing another table and the primary key fields within it. Again, check the syntax, practice with it a little bit. You're not going to have trouble once you get it. We then looked at the alter table command. What we're going to learn is there are about 1 million different variants on the alter table command, and we're going to use a bunch of them throughout the next couple of lectures, so more on that. But we used it here to add constraints to an already existing table that didn't have either primary or foreign keys, and we were able to add those keys with the alter table command. Finally, we ended with a check constraint wherein our shipment type had to be either full or partial, and we weren't going to allow for bad data into our data set by constraining the data set in that regard. All right, I think it was a good lecture. I hope you enjoyed. Again, please practice this stuff before you leave or go too far while it's still fresh in your mind. See you in our next lecture when we conclude the analysis of our log. For now, you go out there and you have some fun. Remember though, learn something every day.